Alright, good morning. Today we are starting adding, subtracting radicals. So in section 1 we learned about radicals. Now we actually learned about rational powers and learned how to change them into radicals in section 1 and 2. And in 3 we learned about simplifying radicals. When I have a big chunk fat radical, how do I bring prisoners outside? That's what we learned, but we didn't really do any 4 operations on them: addition, subtraction, multiplication, and division. In 10.4 we will do addition and subtraction first together, both operations together, because they are kind of the same. But in 10.5 we will learn about how to multiply them, and 6 we will divide them. So they are later. Addition and multiplication and division later, but today add and divide. You can't simply add any 2 prisons or 2 radicals together. There is a special requirement. That requirement is the type of the prison must be the same and the prisoners inside must be the same. What do I mean by type of prison? Type of prison is determined by index, this number right outside. Sometimes it's not visible. If it's not visible, it's 2. So the indexes must match. So I call this type of prison, but technically it's called indexes must match. Not only indexes must match, but the radicand or prisoners inside, x and x, you see, they must match as well. Once you see all these matching, just imagine like you're adding 2 set of apples. You have 3 apples, 7 more apples. All you need to do is add up the numbers in front. 3 plus 7. 3 apples, 7 more apples makes 10 apples. Alright? But this property is technically called distributive property. You are kind of factoring this out. You are factoring, combining this and factoring here. So you pull that prison out of these numbers and joining those numbers in front. 3 and 7 makes 10. Can you follow? Makes sense? So in radicals additions, we only add up the numbers in front if there is a requirement, if the index of the radicals and radicands or prisoners match only. That's the case. For example, you couldn't add these up if this would be y. You can't. Radicands are not the same, prisoners not the same, you cannot add them. Or let's keep them x, but let's make this a cube root. You cannot add them as well. You cannot add these either, because this is cube root, this is square root. Now they are matching. I pull root x's out, combine and make it 1 here, and add up the numbers in front. You're done. Subtraction is the same. If you see a minus sign, sorry, why am I here? If you see a minus sign right here, then you will just make that a minus sign, then it becomes a subtraction. Alright? So let's first practice whether you understand what like radicals mean. So here is question 1, part A. Are these 2 radicals like or not? Are they like? No, of course not, because although the prison type's the same index, but what is different? Different prisoners or radicands. You see 5 and 2 different, we cannot add them, sorry. So we will go ahead and choose on here. They are not like. Alright, let's do second one. Are these 2 radicals like or not? Are they like or not? They are like. Look, only focus on the prisons, not the numbers in front. This is 3, but this 3 is a free guy. It's outside prison. We don't care. We don't compare 3. Only look at the symbol and see if indexes are the same. These 2 don't have index. That means it's 2, both 2. So there is a match in index. Check out who's inside. Prisoners 2 and 2. Do we have a match? Yes. Prison type and inside guys match. So these are like. Although there are numbers outside do not like, we are okay with that. We are only comparing prisons and prisoners. How about these? Same prisoners, 2, 2. You have a square root, and this is a fifth root, fifth. So different type of prisons, they are not like. Okay? They are not like. You cannot add or subtract them. Alright. Once we now competent on identifying like or unlike things, we are ready to add or subtract. Subtract the radical expressions. You see the minus sign, we will subtract them if it's possible. Okay? So first thing you need to check is focus on the radical part and see if they are like or not. What's the answer? Are they like? Yes, they are. So we can combine them into one prison with the numbers in front performing this operation. So I put 6 minus and 3 here. 6 minus and 3 in parentheses and copy one sample of one apple here or one prison here. Do not double the prison. Some people put twice this thing next to each other. No, you only combine them into make one. And what is 6 minus 3? 3. Answer is 3t. 3 square root t. So first thing you need to check is if they can be simplified. Yes, they can. And the answer is 3 square root t. Okay, there are some mistakes you need to avoid. Again, if there are no numbers in front of radicals, no numbers, some people think it's 0. Because you don't see nothing, that means 0. No, there is a secret 1 in front of them. Secret, hiding 1. So you still add them, add those numbers, 1 plus 1, and they make twice 2. 1 plus 1 is 2 root 3.
Index still 2 if it's not there.
Yeah, if the index is not visible, it's still 2, so there is a match in indexes. So these are like radicals. We still add the numbers in front. Here are some mistakes. Most people think root 3 and root 3 can be added by simply adding the numbers inside and making 6. This is not correct. Again, we do not add numbers inside. We only add numbers outside and copy one sample prison here. Okay, this is wrong. So again, we copy one of them here, only add the numbers in front. Another mistake again, do not combine prisoners X and Y. You cannot. Alright, these actually cannot be added. You cannot add these because they are different radicals inside. X and Y different. You can't add them. Alright. Number 3 is different than number 2 in the sense that the indexes are higher. This is a 4th root, higher security prison. Let's say 4th root. But not only that, we have also 3 terms added and subtracted here. 3 terms. 1, 2, 3. In the previous question, you had only 2. First thing you're going to check is the same thing. Circle prisons and prisoners. And see if they are all like or not. Are they like? Are they? Are they all like? Yes. So we make them 1. You make one sample. Don't triple them. Just take one of them here. Open a parenthesis. guess what I'm gonna do with the numbers in front? I will put all those numbers in front in this parenthesis and compute it. So this is plus 4, minus 3, again, 4, minus 3, and nothing. So we have 4 minus 3. That's it? Yeah, we still have another one here, plus, again, if a radical doesn't have a number in front, it's 1. So you need to have that here. So you carry all the numbers in front into parentheses, one sample prison, there, you're done. So this is 2, right? 4 take away 3 is 1, add 1, it's 2. The answer is 2, radical, 4th index, 5. Okay? Yes, can be simplified, we did. And the result was 2. How do you make 4th index? You need to go with the second option, nth root, make 4, right arrow key, go inside and make 5. Okay, next question. It's getting more complicated each time. Well, no, not really. It's still 3 prison, triple addition and subtraction, right? Same deal. So all I need is open a parenthesis, copy one of the prisons, which is root A, and add these numbers. This is 1, 11, plus 11, plus 1, and minus 2 here, and copy one of the prisons, and we're all done. Agree? 12 take away 2 is 10. 10 root A is the answer. Am I right? Now, what did I forget to check? Yes. To be able to combine all 3, they must be all like. All of them should be same prison, same prisoner. Are they all the same? No. Only these 2 are like. These are like. This is not like.
Would you leave that as unsolvable, or
Yeah.
would you combine 11 and negative 2?
We will only combine the green ones. We will still combine the like ones. Red one, not like one, will stay on the end alone. So we will copy that unlike one to the end first. Let's put it here. This is unlike one. We won't touch it. Plus B. Only add up the like ones with one sample prisoners. Root A is the prison. Add the numbers in front. 11 and minus 2 is what I see. You see? So what is 11 minus 2? 9. Root A plus root B is the answer. You cannot combine these 2. You cannot simplify more because these are not like. Okay? Can be simplified. We still simplified it a little bit, not all the way, but it can be. And the answer was 9 root A plus root B. Okay? Are we good? Next. Wow. 2 different variables this time. And both variables are inside. And some of them are outside. Wow. Okay. What do you think?
I don't think you can pull it out.
You don't think we can do that? We'll simplify this?
Can you?
Alright, yeah. The check is easy. Just circle the symbols. Circle the symbols with root symbols, radical symbols, here and there. See if they are like. Are they like? Look, I ignore the stuff outside. This thing is outside, ignore it. Ignore these. Is there anything outside here? No. Just compare this. Are they like? Do you have the same index? Yes, we do have the same index. But do we have the same prisoners? Do we? Are these prisoners exactly the same? No. So these are not like. They are not like. Well, can you make them like with some simple algebra? Is there any way you can bring... Yeah, they are almost same. I wish this was gone. Is there any way you can bring this Q out? Can this Q be saved from prison? Can you bring it out? You try that and no, Q doesn't have any money. Remember, to break prison you need to have a power. If you have a power, money, you can get out. This guy doesn't have it. So Z and Q forever there together, not separable. So they are not like forever. So the word is easy here for this question. Cannot be simplified. That's it. This cannot be simplified. Is it clear? Not like, not simplified. Oh, this is easy too. Just we need to focus on the prisons, right? Same index, but where are the prisoners? 45 and 20? Not like, cannot be simplified. Agree? Yes. Okay. Just because at first sight these numbers different, they're not totally not like. Try to first turn these into powers and save if there are any factors coming from this prison coming out. So first thing you need to do is go back to yesterday and simplify radicals. Before you decide they are like or not, you need to simplify them. I partially did it here. I checked if Q can be brought out. I tried to simplify this and then I decided not like. You need to do the same thing. Can you guys break 45, make it powers and let somebody out? Let's check. Maybe you can. Let's break 45. Pick two numbers multiplying into 45. 9 and 5. 5 is locked. So 5 is going into factor room here. How about 9? 3. These are locked as well. So 3 goes there. Something interesting showed up in the factors. 45 had 5 and 3 squared in it. Let's work out 20 as well and then we decide. 20. 4, 5. 2, locked. It's double squared, 2 squared, double 2 squared, and 5, right? 2 squared and 5. Now see if any one of these can break prison. Can you save 5 from prison? Doesn't have money. It has only 1 power. Can you save 2 from prison? Index is 2. Yes, you pay off the guard. It wants $2. You have $2. So 3 becomes 3 to the first. 3 comes here. Remember, this is what you do. You divide 2 by 2. Remainder is 0. That means this guy is completely out. So 9 and 3 join together and 5 stays in. How about here? Same deal. Guard is 2. This has $2. So 2 breaks prison and comes next to 5, but this 5 stays in. Okay, and please multiply these two numbers now because they are just simple numbers. They need to be combined. It's 27 and this is 10 root 5. Compare now again, please. Earlier they were not like. Look at the new prisons now. After the riot, some of the prisoners escaped. What's locked inside is nothing but just a single number 5. So they are like. So we can combine them. by simply adding the numbers in front of them, which is 37 root 5, right? Correct? So the answer you see has nothing to do with initial answers. Like some people try to add 9 and 5. No, 37 and root 5. So the total change in prison and in the numbers in front. Okay, this is triple operation, 3 terms. Root 2, root 18, and 8 are prisons. 3 different prisons, nothing like here, nothing like so far. But don't give up. Simplify each prison, see if they match. Can you simplify root 2? No, the first one stays as it is. I can't break 2 for more 2's 2. That's it. This is it. How about 18? It's, and then 9 is, so it is 2 times 3 times 3, it's 3 squared. Right? Okay. Can you break 8? Which is, and then 2 cubed. Alright, we're not done yet. We need to let people with money out of prison. Who has money? They want, each guard wants $2. This has $2. When you give away $2, you have nothing. So 3 comes out as 3 squared comes out as 3 to the first 3 out. So 8 root 2 plus 3 root 2 now. 3 comes out. How about this? This is 2 cubed. The guard wants $2. This has more money than what guard wants. So how does this come out? How did we do this yesterday? If the power is more than the index, we do this. Take the money the prisoner has, divide by the money guard wants. How many times 2 goes into 3? 1. 2 times 1 is 2. The prisoner still have $1 left in his pocket, so you need to let that $1 remain in prison. 2 to the first remains, but how many 2's comes out? This is who set free. How many 2's you're gonna set free? 1 2 set free. 1 2. One of the 2's set free. One of the 2's remain inside. We used to have triple 2's. Triple 2's paid 2 of them to the guard and became 1 2 out, 1 2 in. Okay, what else do we have in front? Minus 3. Remember? This 2 comes out. Alright, so let's add up these numbers. What is this? Isn't it minus 6 when you multiply? So when I join all these 3, are they, can you combine them all? Yes, because these are like terms, like radicals. Like radicals all over the place. So we can add them, group them in the parentheses with the single radical root 2. How? 8 plus 3 minus 6. That's 11 minus 6. That's 5 root 2. Okay? Any questions? Alright, it's getting more challenging. Okay, I'll give you 2 minutes to tackle this on your own first. Give me the right answer for credit. Oh, okay. Let's see if this is the right answer. We break all the numbers, and D already have $1 everywhere, so he doesn't have any power to pay off this guard. $2 is what demanded. So only thing you can simplify here is numbers. So we break 8, but a minute ago we did it already, so I'm gonna cheat. What was 8 again? 2 cubed. And not only we broke 8 into 2 cubes, we also took it out as one of the 2's leaves and one of them stays, right? One stays, 2 of them leaves as 1, okay? 18, have we broken 18 yet? I think we did, right? It was 2, 3 squared. So I will only break things once every day. So 3 leaves, 2 stays. Why? Because 3 has exact $2 change. So double of them leave as a single and 2 stays. And 50, maybe we didn't break 50 yet today. It is 5 times 10. Locked. 10 is 5 and 2. Oh, it's double 5 and single 2. So double 5 is gonna leave the prison as single 5. Right? 2 divided by 2 is 1. And 2D remains. So it's 3. No, not 3. 2 times 2, 2 times 3 is 6, right? 60 minus 5. No, 2D minus 5 2D. In total, how many 2Ds do you have? 665 minus 5, and that's 7 root 2D. Great. Good job. Alright, here is next. Wow, what a mess. Okay, this is a little bit confusing to read, but this is b cubed, okay? This is b cubed. Look like they are far apart, but it's b cubed. This is cube root of 27a to the 7. Cube root 2a squared. This is squared. A squared. You know what to do. Compare initially these prisons. They are not like. So simplify those prisons. See if they become like.
Radical A.
14
Like the A squared.
a squared.
B cubed. A. But yeah.
Okay. Any different answers? Anything different you found? Alright, let's simplify these prisons. A has only $1. Is he leaving anywhere? B has $9. And they want $3. How many B's can break prison? 3. How did you get that number B cubed? Because you divide 9, you have $9 into 3 ways. 3 goes into 9 3 times. So no b's left inside. All these will go away. Nothing left. But how many will pop up outside? B cubed many. So let me write this. 2a squared b cubed is out. A is there forever under the cube root. Okay? Next. Oh, I have a big fat number I need to break. 27 becomes 3, 9 becomes 3, 3. 27 is 3 cubed. And a to the 7. This is our $7. God wants $3. So I need to divide 7 by 3. 3 goes to 7 twice. 3 times 2 is 6. There is 1a left. 1a left in double a out. 2a's out, double a square out, 1a left. 1a left in. Let's do that. Double a out, 1a in. What happened to a cubed, by the way? 3 cubed. 3 and 3 cancels. 3 is out. So 3 comes right all the way out next to the number. So I moved this not only in right before present, but all the way in where the other number shows up, so I can combine them to 12. There is nothing to be done in the first part. So let's rewrite everything again. 2a squared b cubed plus 12. Can I flip the order of these two? Can I write a squared first? I want to write a squared first so that it can look like this one, okay? It's cubic root. Now, are these prisms like? Yes, so we can combine them, add them into one parenthesis, and these guys combine into one prison, and dump everything left here. Dump everything left here. This guy is left here. This seems like the final answer, but it's not. Look, there are more things common here. A squared is common in this. B cubed is common in this. Can I also move these guys out, factor them out right here next to the prison, outside prison? Factor. These are common terms. I'm factoring those common terms out. So only thing left inside the parentheses is 2 and 12. A squared and b cubed are GCF, greatest common factor of each. So they will move outside and become, these two will become 14. So the answer is 14a squared b cubed a under the cube root. So the answer is yes, right. Okay. So let me repeat. After bringing the prisoners out, I've noticed that a squared b cubes, these are like among the terms. So I also factor those like terms here, factored them. So the only thing remaining would be only numbers, and I added them. 2 plus 12 is 14 of a squared b cubes, and then the radical. Alright, and I think most challenging question of the day remains here. Wow. If you get this right, that means, yeah, you mastered your radical skills, okay? If you get this right, of course. Just take your time, slowly work it out. Our work, okay? Alright, we work inside out, see the ones with money can break the prison and what they turn it out when they break the prison. Like cube can easily pay off square. Again, how many times it goes into this once. There will still be one Q left. So there will be one left. So here is one left. But there will be one out. So this Q will move out right here. One move, one in. QW, QW. Okay, how about this one? Yes, $2 in the pocket, $2 demanded, so they will pay off. And this guy will go join in this guy. One more W coming in, and they make square. So in the first radical, you have QW square and 12Q left. Is that correct? No, I missed something. We need to break down 12. 12 is 3 times 4 or 3 times 2 squared. So 2 squared will join this group right here as 2. 2 squared will be 2. And only thing left will be 18W squared 3Q here. Can you follow? Am I too fast? Again, 2 came out and joined to 9 and made 18. W came out and joined to W and make W squared. Where is the Q? I forgot that, but there is a Q here. The Q also... Oh, I'm sorry. You're not telling me. This is not 9. This is Q. So 2 is not joining anybody. Yeah, I hate when they use Q because my 9 and Q look the same. So this is just 2 done. 2 and Q. So it is 2W squared Q, 3Q. Alright, coming up next. 4/3. Again, another W squared coming out and combining and making this W squared. Same deal. Q cube as in before. 2 of the Q's leave outside as Q and 1 of the Q stays in. So still Q is in. 1 Q out, 1 Q is in. But 75 breaks as 5s and 15 and 3 and 5. So double 5, single 3, 5 square and 3. One of the 5s will leave, one of the 3 will stay. 3 is staying, 5 is coming out and joining into 4 as 20. Because 5 times 4 is 20 over 3. Okay? Finally, the last one. 27 is 3 cubed. One of the 3's will go and join right this one. Because cube has $3. There will be 1 left. Same deal here I did. There will be 1 left, 1 moving. 3 moved out and combined with this made 9 over 2. The other 3 will stay. Q it doesn't have money, stays. W square moves out, joins this W and making it W squared. There is already a Q here. This is 9. This is Q, 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 Q. And that's it. We all have like radicals now. 3 radicals all like, so I combine them into 1, 3 Q's. But in parentheses, we will have all this junk. 2W squared Q, 20 over 3 W squared Q, and minus 9 over 2 W squared Q. This is Q W squared, but I can flip it into W squared Q's. Oh, I noticed that there is still common things in this parentheses. Greatest common factor is q squared, w squared q. I can move them also outside. Only add the numbers inside, which is this. When these red circles move out, q squared, w squared q. How do you add fractions or whole numbers? You need to set common denominators here. I think they will set at 6. So this one needs 6 top and bottom. This one needs 2 top and bottom. This one needs 3 top and bottom. 2 times 6 is 12. 2 times 20 is 40. 3 times 9 is 27. Subtraction. And all common denominators 6. W squared q 3q, and guess what these make when you add up? They make 52 take away 27, 25. So it's 25 over 6 W squared q 3 q's. Okay, all right. I found w squared cube, but you can flip this and make q w squared if you want. Okay, same deal. Alright, we'll meet tomorrow.